Well, that was a rather interesting and rude interruption. So it goes, apparently when you get a phone call, when you record on your video camera on the phone, your video ends. So we're going to pick up with primary alcohols. And we were talking about the carbon, where the OH, which makes it an alcohol, is attached. Now, when you look at this carbon, there are three possibilities to continue a carbon chain. But if I block off two of them by putting a hydrogen on there, hydrogen can only make one bond, so this is the potential path to continue your carbon chain. So if I did this and they were all hydrogens, we called it the simplest alcohol. You could call it methyl alcohol, but most people would just abbreviate it and call it methane all. Well, in a primary alcohol, the OH is always terminal. It's always on the end carbon. So if I had two carbons, once again, this OH is sitting on the end carbon. It's on the first carbon. It's always on number 1, so you don't need to give it a number. There's only one path. These are all hydrogens on the ends. If you don't write them, it implies hydrogen. So there's one path for the carbon chains. This is ethane all, two carbons, eth, single bonds, ane, alcohol, OL. If I have three carbons, my prefix is prop. If I put my OH out on the end, either here or here, it's one propane all. Now, you say, why did I use a number here? Because if it's here or here, either way, it's number 1. You could call it 1-ethanol, but there's no need. It's redundant. This is a primary alcohol because there is one continuous chain of carbons. So I would classify 1-propanol as a primary alcohol. Okay, well, keeping 1-propanol in mind, next card, secondary alcohols. Let's go back to a chain of 3 carbons. If I put my OH here or here on the end, the terminal position, I called it a primary alcohol. But what if I put my OH here or here? If I look at my main carbon, what I'll call the main carbon, that's an interior position. So my carbon chain continues this way and that way. 2 paths to continue the chain. The hydrogens that are here and here and here and here and here and here and here, they only make one bond. That ends the chain, but I can always pop off a hydrogen and put as many carbons on there as I want. If there are 2 paths, we call that a secondary alcohol. So if this is carbon number 1, number 2, number 3, or 1, 2, 3, either way it's a number 2, I would call this one 2-propane all, 2-propanol, which you know as isopropyl alcohol, because it's an isomer of propanol. We got away from using iso when we went to IUPAC. It's the numbering system. It's much more consistent. You'll find that it's once you get it, it's a good system. It really is. So 2-propanol would be an example of a secondary alcohol. Next card. Well, if you can have primary, meaning 1 path, secondary, meaning 2 paths, carbon makes 4 bonds. What about tertiary alcohols? Three paths. So here's a carbon. Carbon makes 4 bonds. I'm going to put my OH here. If I put a carbon here, and a carbon here, and a carbon here, I have 3 paths. Look at your main carbon. Here it is. I'm connected to 1, 2, 3 carbons. So that makes it a tertiary alcohol. So how do we name that one? I'm going to redraw it so it's more clear. All the dashes are hydrogens, okay? What's your longest continuous carbon chain? 1, 2, 3, 1, 2, 3, 1, 2, 3. Either way, 3. Let's just make it a straight line, make it simple. So let's say that this is my carbon chain. 1, 2, 3, or 1, 2, 3. Either way, what I called my main carbon is carbon number 2. Chain of 3, that's prop. Single bonds, that's ane. OH group on it makes an alcohol, propanol, but it's not just propanol. I also have a methyl group. Oh, and by the way, where was that OH group? What carbon was it on? Well, it's on the second carbon, so it's a 2-propanol, and it's got a methyl group on the second carbon as well, so it is 2-methyl 2-propanol. And in fact, this 2 is redundant because if you're going to put a methyl group on, remember you can't add on to the end of the chain. You just changed the root. So this one is kind of redundant, but not incorrect. All right, so we had primary, secondary, and tertiary alcohols. Oh, you think alcohols are done, do you? No, they're not. So what if we put 2 OH groups on there? Next card, diols, also known as glycols. Diols are not uncommon even in nature. If I'm not mistaken, the material in plants that make you itch, things like poison ivy and poison oak, that's a diol. I think it's uradiol. 2 OH groups stuck onto an organic molecule. So, other side of the card, 2 OH groups. So if I had something like this, let's put an OH out over here, and you don't write OH again since it's the O that's making the double bond, you put OH, and if you put a dash in between the O and the H, it's okay, it doesn't really matter. This would be a diol, also known as a glycol. So what is this? Well, what's your longest carbon to carbon chain? I've got 2 carbons. Prefix for 2 carbons is eth. And it's got a single bond in between the carbons, so that would be ane. And it's got 2 OH groups, so I'm going to actually keep the E on there and call it ethane diol. But where are the OH groups? On the first and second carbons. 1, 2 ethane diol. Now that's antifreeze for your car, the green stuff that you don't want your pets to drink because it'll kill them. They used to call this ethylene glycol. Eth and ethyl and ethylene, it's just, they got goofy with the, you think ylene, you're thinking double bond, it's not. So it's an old school name, but it's still, it's old habits die hard. Glycols are diols, they are synonymous. So if I had something like, I don't know, let's do that one. What's your longest chain? 4 carbons, 1, 2, 3, 4. Prefix for 4. Bute. Single bonds. Ane. 2 OH groups. Diol. Is it 1, 2, 3, 4? Are the OH on the 2 and the 4? Or is it 1, 2, 3, 4? 1, 3 or 2, 4? 1 is lower than 2. Always pick the lowest possible numbers. So this is 1, 3, butane diol. It's very consistent. IUPAC is a wonderful thing. All right, next. If you can have 2 OH groups, can't you have 3? Next card. Triols. Glycerol or glycerin. If you're a Bush fan, that band out of the 90s, Glycerine, that's what he's talking about. One of the ingredients for the hand sanitizer, they're basically taking ethanol, 80%, 160 proof corn liquor, adding a little bit of glycerin to it so it doesn't dry your hands out like crazy, and it's killing the viruses on your hands. They're making it locally now. They're not making the whiskey anymore. They're distilling alcohol until it's roughly 80%, mixing in a little bit of water and a little bit of glycerin, and they're calling it hand sanitizer. Good for them. All right, so 3 OH groups. So if I had 1, 2, 3 carbons, I don't have to have 3 carbons, but I can. I'll put an OH here, an OH here, an OH here. What would you call that? That's the glycerin or the glycerol that they're adding to the hand sanitizer. But what is the IUPAC name for it? Well, 3 carbons. That's pro. Single bonds. That's ane. 3 OH groups. That's triol. Which carbons are they on? Well, one's on the first one, one's on the second one, one's on the third. 1, 2, 3 dash propane triol. That's glycerol. Glycerin. By the way, you heard of nitroglycerin? Stuff, building blocks. So if you put nitrates here, nitrate has bonds between nitrogen and oxygen, stores a lot of energy. You've got hydrogen, you've got carbon, you've got oxygen. Nitroglycerin is the kind of stuff, it's liquid. If you drop it, it explodes. All right, next ones. Enough with the alcohols. Let's talk about the world's first anesthetic. Back in the days of, say, the Civil War, when they said bite the bullet, that was literally bite this piece of lead because I'm going to hack off your arm or your leg or whatever got shot with the bullet because it's getting gangrene, and if you don't cut off that limb, you're going to die. They didn't have things like anesthetic, and then shortly thereafter they figured out that if they took a piece of cotton cloth and put it over your face and put a few drops of this liquid on there, and the vapors were more dense than air, they would sink into your lungs and they would knock you out, but they wouldn't kill you, and they could cut your limb off in peace before you woke up. Still sounds rather horrific, but it's the basis of anesthesiology. Ether. So ethers knock you out. Ether's also the stuff of starter fluid. If you have a small engine that won't start and you have this spray bottle and you spray some in the carburetor, for those of you working on lawnmowers or snow blowers or things like that, you can still get this stuff at auto stores. It's a very powerful odor and it's very dangerous. It's very flammable. It's no good for you. They're carcinogenic and mutagenic, but wow, do they burn, and they will help you clear out the bad gasoline out of your carburetor and get your engine started. So ethers give you a little bit of rest or relaxation. I'm going to call this ROR prime. So you've got an oxygen in the middle doing this bridge thing. Oxygen makes 2 bonds, and if you put some carbons to the left and some carbons to the right, you have an ether. So there are different ways. I've talked to different professors, and I don't know if there is an accepted convention. Some people say, well, you go alphabetical, and you say, well, if this one is, lower alphabet than that one, put this one first, and if this one's, lower alphabet, put this one first when you name it. Others say, well, you go with the smaller one, then the bigger one. I think it depends on who you talk to, but as long as you list them both. Ethers are the only ones that aren't really logical in the IUPAC system because they go one side, then the other side, and then the word ether to tell you there was oxygen in the middle. So as an example, here's oxygen straddling a methyl group over here and an ethyl group over there. That's methyl. That's her sister ethyl. Now, I don't care if you call this methyl, ethyl, ether, or if you call it ethyl, methyl, ether. I have talked to professors that say either is acceptable, and people can argue that until they're blue in the face. See, there's, the same people that say, well, it's too positive, not plus two. I'm not going to give credit for it. Well, it means the same thing. So one side, then the other side, then the word ether. That's a little bizarre. That middle portion implies ether, or ether implies that's in the middle. So if I were to give you, for example, dimethyl ether, sounds so violent. Start with the ether. Do this. Dimethyl. Well, you have two methyl groups. Oh yeah, you've got a methyl here and a methyl there. See, not too hard. What if I said methyl propyl ether? Start with the word ether. Do this. On one side, put methyl. I don't care what side you put it on. I'm going to pick this one. On the other side, prop. I need 3 carbons. 1, 2, 3. Methyl, propyl, ether. Next, aldehydes. Now, aldehydes and ketones are very similar. So, aldehydes are terminal and ketones are internal. But what is terminal and what is internal? You're looking for a carbon double bonded to an oxygen. If it's an aldehyde, to make that terminal, we know that carbon makes 4 bonds. Well, if I block off this path with a hydrogen and have the only other path right there, I have a carbon double bonded oxygen, a carboxyl group, and a hydrogen on the end carbon. So sometimes this is R-CHO, and I hate they do that, but they go CHO because they don't want to go COH because it would look like an alcohol, but aldehydes are CHOs. All right, so if there's just one carbon and it is the only end, usually when there's only one carbon, they call that the basis, the form of the particular class of compounds. This is formaldehyde, but the IUPAC name is methane-al. Al at the end implies aldehyde. Very subtle. Al, aldehyde. Ol, alcohol. Aldehydes, they put the H there so it doesn't look like an alcohol. Now, if I've got more than one carbon, it doesn't really matter. You don't need a number for the aldehyde because the aldehyde is always on carbon number 1. So, I don't know, 1, 2, 3, 4, 5. If on the first carbon, the end carbon, I've got double bond oxygen and a hydrogen, and all of these are full. 1, 2, 3, 4, 5, that's pent. Single bonds, that's ane. That's al, because it's got a CHO at the end. And if you want to put the 1, it's not wrong, but all aldehydes are number 1. That's not very different from ketones. So here you've got that carboxyl group, but it's in the middle of a chain. It's an internal position. So you've got carbon to the left, carbon to the right, so we'll call this R, and we'll call this R prime. And since this is an interior position, once you get up over 4 carbons, you need to give it a number. But you can't have just 1 carbon for a ketone. You can't have just 2 carbons for a ketone, because either way it's on number 1. So you need at least 3 carbons. Here's 1, 2, 3 carbons. And if I put the carboxyl group in the middle, that carbon's already got 4 bonds. Fill this one up. I could call this 2 prop ane, the O-N-E tells me it's a ketone, but this 2 is redundant because there's only one internal position in a chain of 3. But ONE tells me it's a ketone. Same kind of deal with 4. 1, 2, 3, 4. Whether I go here or here, it's always number 2. So I could call this, by the way, don't put the dash down here, that's where people go wrong. You've already got 4 bonds in that carbon. I could call this 2-butane-one, but this 2 is redundant. But after I get up past 4 carbons, 1, 2, 3, 4, 5, let's put it here. Five is pent. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. 2 is lower than 4, so I would call this 2 pent-ane-one, which is an isomer of 3 pent-ane-one. So after you hit 5 carbons, you're gonna need a number. Now, that's really helpful, this column on table R. If the example they give you has a number, you know in your naming conventions you need a number. If the example they give you doesn't have a number, you know that your compound is not going to need a number. It's kind of a dead giveaway. I like that. They give you good examples here. All right, so we did aldehydes, we did ketones. They're very similar. Next one is an old familiar friend. Organic acids, sometimes called carboxylic acids. So you're going to have that familiar carboxyl group with a hydroxyl group. It's always terminal because carbon only makes 4 bonds and it's already made 3. So here's your R. This is a slightly different class of organic compounds because, as we know from our other unit, this hydrogen has a tendency to leave the electron behind and wander off as an ion, and it makes the remaining part of the compound another ion. So organic acids are actually electrolytes, albeit weak. Acids ionize when they get into water, much less than 1%, as we know from our icebox problems, but enough to conduct electricity. So if we have just 1 carbon, there it is, OH, and if I just put another H there, the old school name would be, hey, that's formic acid, because it's the form for organic acids. You know, that's the stuff of like ants that bite, or stinging ants. That formic acid is one of their chemical weapons. It burns. But the IUPAC name is 1 carbon, methanoic acid. And it's always at the end, so if I have 2 carbons, ethanoic acid. 3 carbons, propanoic acid. I don't need a number because it's always a number 1. If you use a number and you make it number 1, it's not wrong. It's redundant. But if you use a number other than the numeral 1, it is wrong. All right. I'm going to pause the video. We'll do this in sections. I'll put a bunch up today. I was interrupted on the first one, but these take forever to upload. So we'll go to the remainder of them on the next video.